Welcome to the class, Tatu. Just give me indication that you can hear me. Okay, just give me indication if you can hear me. Okay, great. We'll have to speak in this lecture. So what you need to do is unplug your mic and just plug it in again. There we go. Your mic is, you've played with the mic. I can see you've played with your mic. Just speak again. Okay, if that's still not working, Tatu, just exit the meeting and then you enter again. So just get out of the meeting and then you just go in and again. Just go in again, and then we'll your mic should work. Okay, what now? Just speak up and adjust the volume of your microphone, make it a bit louder. I can see that you are talking actually, but the volume of your microphone is either turned down almost fully, or just plug it out and plug it in again. Just unplug the microphone, pull it out of the computer, push it back. There we go. Speak up. So Windows
Yes.
is always trying to fix the problem for you. Now, it's probably selected the internal mic or it's just shut that mic down because it wasn't working. Sometimes when you
Yes.
unplug it and plug it in again, or you go to the settings, once you go into the settings, it registers that settings in its operating system and then it works. Okay, good.
Yes,
We
sir.
completed
Stoichiometry.
concentrations.
Yes, sir.
Now, according to me, that's the final part of your chemistry. for the-
Chapter. Yes, sir. That's the final part.
Okay. Do you have any questions on work you've done recently that we first need to do?
So I've been practicing my paper one because it's coming soon, and I
Yes.
would like for us to do mechanics and electricity and magnetism.
Are you writing on electrical current? I don't think so.
That's gonna be in paper one, sir.
Electrical currents? Really? I
Is it
didn't know that.
in,
Okay, good.
in paper
Which
one?
one do you just want to start with?
I actually wanna, or if you can't do electricity and magnetism, can you do mechanics, wave, sound, and light? Yes, those two.
Do you want to, which one first?
Mechanics.
Mechanics. Okay, so that's basically Newton.
Yes, sir.
Right, okay. So we are going to do Newton 2 and 3 because 1 is just a little small part that you have to physically learn. There are no calculations with Newton 1. There's only a definition that you have to learn and stuff that you need to explain.
Yes, sir.
Okay, so Newton 2 and 3. Okay, let's do some random stuff on that.
Okay.
Okay, let's assume we also have to do revision on vectors then on a later stage. Okay.
Yes, sir.
Right, let's assume that I have a surface there and there's a box or a object with a weight of 10 kg. 10
Yes, sir.
And I have a kinetic coefficient of friction of 0,2. And then there's a frictionless pulley system with a rope and a
Yes, sir.
mass of 3 kg. Okay, so I'm just going to move this to the side. This is like a classic sum. They're going to maybe
sir.
make T there for the rope or tension in the rope. So the first question is going to be a free body diagram of either one of them. They're going to choose the 10 kg or the 3 kg. So let's do 10 kg.
Free
Right, help me.
body. Okay. So first, sir, we have a force that is going to the right, which is the tension.
Okay.
Okay, we have the force going down as the gravitational, the
FG.
gravitational pull.
Do you use
should-
FG or do you use W for weight?
You use W for weight.
Okay, good.
There's
Doesn't
a force
matter.
that's going.
Yeah.
Okay, sir. There's a force that's going to the left, which is the friction.
Okay, you can use F or you can use FK. Doesn't matter.
Oh, yes, sir. Is the force going up, sir, for the normal force?
Yeah, normal.
Yes,
You
sir.
can use Fn or just N.
Yes, sir. And there's another weight going down as the 3 kg, I think.
Yeah, but that's not on the 10 kg.
Oh, we calculating the 10 kg. Oh, yeah. Then
Yeah, okay,
that's
we
it.
can do both. Okay, the 3 kg as weight down and
Yes,
it is
sir.
tension upwards.
Upwards. Yes, sir.
Okay,
That's
good.
all.
So what the next question is going to be, if they want to make the sum fairly easy, they'll ask you to work out the kinetic friction. If they want to make the sum harder, they'll ask you acceleration of the system. So
Yes, sir.
in this case, we're just going to split it up into two parts. The next one is, please calculate the kinetic friction.
Okay, can I finish drawing the free body
Finish drawing this.
diagrams? There must always be a dot right in the center.
Yeah, there must be a dot in the center.
Okay.
And in
So now
exam,
we
you
can-
use a ruler to draw them.
Yes, sir.
It's not penalized, but the normal and the weight component arrows must be around about the same length.
What is the kinetic friction? Right, sir?
No. These two must be around about the same length.
Yes, sir.
Yeah, the other two doesn't matter that much. They can't penalize you for length, but if you're going to make it ridiculously short compared to the other one, they're going to interpret that as you trying to say something that
Yes,
they're
sir.
not the same, and then you're going to lose marks. Right, let's go. FK.
Yes, sir. Um,
Equation. Mu K N. Is that correct?
yes, yes, sir.
But N minus W is 0.
Yes, sir.
So the normal force equals the weight.
Yes,
So the kinetic friction is the coefficient times mg, because weight is mg.
yes, sir.
Good. The kinetic friction is 0.2 times 10 kg mass times 9.8. I think that's 19.6 to the left.
Sir.
Is that 19.6?
Sir,
Yes.
how do you memorize like the equations, sir, and the formulas?
I don't memorize them. I've just done enough sums so that I know them. But you don't need to memorize them. You just need to you just need to know where they are on the formula page. The more examples you do, the more you will remember them.
Yes, sir.
I've done more sums than you have. Eh?
Yes, sir.
Okay, you understand what we've done now.
Yes, sir.
And then the third one is going to be, what is the tension in the rope
Okay.
or the acceleration? Doesn't matter. Tension in the rope is just one step further. Okay, I want to find out what method are we going to follow. That's very important. The method is F-net for both. Do you use F-net or F-res?
Fnet, sir.
Okay, so we're going to set up F-net for both of these, for the 10 kg and the 3 kg, and then we're going to solve it simultaneously.
Okay.
Right, so these diagrams teach us exactly what to do. They show us exactly what to do. If I look at the 10 kg diagram, we're choosing the movement towards the right as positive.
Sir?
Is that right?
Yes, sir.
Or to the right down if you want to do that.
Yes.
Okay, so the friction is negative,
Okay.
plus a positive tension in the rope is 10A. That's my 10 kg setup. So I've got negative 19.6 plus the tension in the rope, and that will be 10A. And that's my first equation. Now, what I normally do, I just make tension the subject of the equation. Tension is 10A plus 19.6. And then I set up a second equation with the 3 kg. Tension in the rope is now negative because it's upwards.
Yes,
Plus
sir.
the weight component is 3A. So negative tension plus mg is 3A. I'm going to make tension of the rope the subject again. M is 3 and g is 9.8 minus 3A. And that's my second equation. And then I'm just going to make them equal to one another. Because I made t the subject of the equation, I can just set up those two equations equal because both of them are t. So 10a plus 19.6 is exactly the same as 3 times 9.8 minus 3a. So I've got 13a this side, and then I just do 3 times 9.8 minus 19.6. And then I get 9.8. That's interesting. Yeah, obviously, it's 3 times 9.8 minus 2 times 9.8. That's 1 times 9.8. And I divide that answer with 13. So I get the acceleration of 0.75384. I don't need to write anything here. I don't need to write the direction. Why? This is not the question.
Yes, sir.
This is just a stopping point in the sum. And now I can choose any of those equations. Like the
Then,
first one, for instance, to work
yes,
out
sir.
the tension. You with me?
Yes.
The tension equals 10 times your answer you just got, 0.75 plus 19.6.
0.7538.
Yeah, but I'm just have the
Oh,
answer in my calculator. I have this long answer in my calculator, so I'm just going to multiply it with 10 and then
yes,
add
sir.
19.6. 27.14. The tension in rope is 27.14 Newton. And tension in rope does not have direction.
Yes, sir. Hmm. Can you, sir?
Yes.
I keep on struggling every time I type in like questions to practice with.
Where do you type that in?
Google.
Yeah, but I can give you lots of examples.
Yes, sir.
Why don't you just type in past papers, grade 11 physics?
Then I should get whatever I need from there.
You should get a lot from there. Remember, you can go onto the government site and also get all the
Yes,
papers
sir.
from grade 11.
Mm-hmm. Yes, sir.
Okay, good. Now we've done
Next
a flat
example.
surface.
Yes, sir.
The next example is like a surface at an angle of, let's say, 30 degrees. And there's a box there. And this one is 8 kg. And I have a S value. Okay, now I must make sure. Let's just, of let's say 0.5. No, that's too much. Let's say 0.4.
Okay. We have 30 degrees for the angle.
Yes. And we have a box there weighing 8 kg or object. And what does that, what does S tell me?
That it's static, that it's not moving.
Not moving. Okay, very important. That might not be the maximum S value. That's just, if I increase, what's going to happen? If I increase this angle, if I make it bigger, then the box may still stay put.
Yes, sir.
And then suddenly it start moving. Now at a certain angle, it will start moving. I can tell you it will move. Oh, shucks. It should move at 21.8 degrees. Really? So I just want to check something. That was too low. That 0.4 was too low.
Okay.
Yeah, it's too low. It will move. The box will slip. So let's make it 0.6.
0.6.
Yeah,
Okay.
it's very high, isn't it?
Yes, sir.
No, it won't. It won't move. We can choose any value we want, as long as we don't call it max. So we can go back to another value. Let's say 2.5. Just want to make sure it will work. So tan theta is mu. Tan 30. The maximum value will be 0.57. Okay, fine. So we're fine. Let's leave it 0.25. That's low enough. So it's not moving.
Yes, sir.
Good. Right. So let's just work out the following. I want to free body diagram. Quickly do that, or help me draw that.
Gram. Right. So, okay. You're going to put the dot to represent the thing. Right,
Yeah.
sir?
Yes.
Then I'm guessing there's going to be a gravitational force downwards.
Okay. You want to do
Which
this?
is weight. Yes, sir. Which is
Okay.
weight. There's one going up representing the normal force.
It must be perpendicular to the surface, eh?
Yes,
The normal
sir.
force.
Then we're gonna one be going yes, sir, that's for the
Upslope,
static friction.
which
Yes,
is
sir.
static friction.
Friction. Yes, sir.
Okay, now, very important. This is full marks. 1, 2, 3 marks. The better diagram looks like this. This is a better diagram. I'm going to convert that weight into a parallel component and a perpendicular component.
Yes, sir.
Okay, so both of these are right. The bottom one is also 3 marks, but the bottom one is a better drawing because it allows you to see which forces are basically parallel to one another.
Yes, sir.
Those. So I know impact on the memo last, they only had the top one. And if you draw the
Yes.
bottom one, then some students were marked wrong. I'm very skeptic about who's marking your papers at impact. I've got the idea
sir.
there's someone marking it that doesn't know a lot about science, because some of the stuff that's marked wrong, they don't have other memo options for, which is wrong according to me. Okay, anyway, it doesn't matter. Let's do, this is one. Number 2, what is the static friction? Let's calculate the static friction.
What is the can I do it, sir?
Yes.
Okay. Static friction is supposed to the weight is
There's 2 ways of doing it, eh?
yes, sir.
Method
Static
1.
friction.
Me is in. The other method is what? Okay, let's do this method together. The static friction is the coefficient
Yes, sir.
times the normal force. But the normal plus a negative weight perpendicular component is 0. And this
Yes, sir.
this is what this bottom one is showing me. These 2 forces are in equilibrium, or they are the same. So the normal force is equal to the weight perpendicular. But what is the weight perpendicular? Can you remember what that is? Is that what? That's mg sin or cos? Cos alpha.
Oh, yes, sir.
So that's the mass times 9,8 cos 30. That's normal force. You can type that in, or you can just convert that into your answer. 8 times 9.8 cos 30. So that's 67,8963 Newton. And then I can convert it in there. So I'm just going to multiply that 0.25. So my static friction is 16,97 Newton. Slope up.
S equal to 16,97 Newton. Must you write up slope, sir?
What do you normally do? Well, it's a vector, so you have to give direction.
Oh, yes, sir.
There's another method of doing, another way.
Yes, sir.
You can look at these 2 blue forces. They're exactly the same.
2.
So the
yes, sir.
weight parallel plus negative static friction is 0 because F net is 0. So you have to write F net is 0, and then you can say that the parallel force is equal to the static friction.
Okay.
So the static friction is the parallel, which is mg sin alpha. And that's mass times 9,8 times sin 30.
S. Okay, then F S equals
So we have a
to
small problem here. Oh, small problem. I've got 39,2 now. Is that true?
okay. Let me type it on my calculator to see if I get the same answer. Sine 30. I get the 9,2 also.
This is a problem. I just want to see where's our problem. So there's a huge difference between those 2. Why is the red one wrong?
The red line is wrong.
Yeah.
Because oh,
Because I
because
guessed that static friction value. So to make sure it can work.
so
Yes.
remember when you're like the normal force is equal to the weight parallel equals 0, right?
Yeah.
Doesn't that mean that N is equal to negative weight parallel? Or that can't
Not
work.
weight. No, weight perpendicular.
Weight can't be negative. Wait to oh yes, I mean.
So to make sure we've typed in that 8 times 9.8 times cos 30. We've done that right. That's the normal.
Force, yes.
Yeah, and then we multiply it with 0.25. With 16,97. I know what the problem is here. Just want to check here. That is the problem here. That value that I guessed. That is the problem. Just want to work out. Okay, that's the coefficient times 67.8963. Yeah. Okay, this is the problem. Sorry, man. This is a small problem. I just need to fix it. That value there must be 0.57, 0.58.
So must I restart the whole thing?
No, we
cross
don't
out?
have to restart the whole thing. You can just change that. And then we
Yes,
change this one value here. So I can't just choose there. I have to work it out. That's 0.58. And then this value here would be 39.2. Same.
okay.
Okay.
58.
Yeah, they have to give you, in order to do this, we have to work with a maximum static friction.
Yes, sir.
No.
9,8 sine 30 equals 39,2. Yes, sir.
Okay. Otherwise, the one method won't work. I've just chosen there the value to make it less than the max, but I couldn't. What happened is I actually made it more. I made it more.
Yes, sir.
I made it slip. I made it slip too soon. So in other words, that it would not have been static with that other value. Okay, that's what I did.
Yes, sir.
Okay, good. So this is fine. You can work with it with this, and then obviously I want to know what the acceleration is. Number 3, what is the acceleration? If
What is
net ma
equals is
okay, now we look at the blue part of our free body diagram. The weight parallel is positive, and I'm adding a negative static friction, and that is 8a.
net.
The weight parallel is mg sin alpha minus that 39,2 we just got, and that is 8a. So I have, is it 8 kg? Yeah. 8 times 9,8 sin 30 minus 39,2, and that is 8a. No, man, this is wrong. I didn't want that. The acceleration is 0. They won't ask you that. I wanted to add something else. Okay, number 3. Let's assume that the angle changes to 45 degrees. What is the acceleration then? Okay, then it will actually, what happens now? It just starts moving. Okay.
So
What needs to change too? Something else needs to change.
something else needs to change.
Yeah. Look, once it reached the maximum static friction, that will be 0.58. Once it starts slipping down, the friction will change.
Yes, sir.
This is a huge sum, actually. I think we need to just make another sum of this. I don't have enough paper space. But you can't use, they can't use this value if the box
Oh,
stops
yes.
moving. They have to give you a new coefficient of friction or new friction values. Okay. Or they should have said, the angle changed to 45 degrees and the kinetic friction is then 65 Newton. No, sorry, not 65. 35 Newton. So once it starts moving, the friction will actually go down. And then you can work out the acceleration. What is acceleration?
You can still use F net equals to MA, right?
Yes, you can still use F net equals MA. Now you still have that same W parallel force plus negative friction we've got now, and that is 8A. So that's not difficult then. Then you have to work out this parallel, which is mg sin 30 minus the 35 Newton friction is 8A. Now we can do that. And that is the mass times 9,8 times sin 30, it's a half, minus 35 equals 8A. Now we can do that. In the previous sum, it didn't actually move yet.
Where's my calculator?
I get 0,53. 0,53 meters per second square downslope. See if you get that.
0.53, yes.
Good.
4,2 equals 8. A equals 250,53 meters squared. Meters per second squared downslope.
Right, so we've done two of these. One with a flat surface, one with a surface that's at an angle. We can also add another block. But before we do that, I just want to do a bit of Newton 3. So we have a flat surface again. And there's a block, let's say 6 kg. And there's another block attached to that, which says 3 kg. Someone's pushing it this direction. Okay, I'm going to give you the friction in both. The friction here is, let's say, 8 Newton. And the friction on the 3 kg block is 4 Newton. And someone is pushing it with a 20 Newton force left. Okay, first thing, free body diagram. Let's just write this. Free body of the 6 kg. Give me a free body diagram of this 6 kg block.
Yes, so of the 6 kg.
Yeah. We're going to draw both, but let's just do 6 kg first.
Okay, so 6 kg. Well, there's a downward force that is representing the thing, the weight.
Right.
Yes, sir. It's moving towards the left, so there's that force also.
What is that force's name?
It's force applied.
No.
Force applied.
No. The force applied is only on the 3 kg block. No one's touching the 6 kg. So it's the force of the 3 on the 6. The force to the left is the force that the 3 kg block exerts on the 6 kg block.
Yes, sir.
No one's touching the 6 kg block. There's no applied force. And then towards the back, there's
friction. There's the friction.
Okay, so this is a 6 kg block. Then there's also a free body diagram we can draw of 3 kg if we have to. Well, you'll have to do that in order to do the sum. There's also a normal force. There's also a weight component.
Yes, sir.
Then to the left, there's
force applied.
Force applied. To the right, we have the force of the 6 on the 3 And also to the right, we have friction. Look at that one.
Yes, sir. Can I just finish
Yeah,
drawing?
quickly draw those two.
Yes, sir. Okay.
Good.
And
Now they want the acceleration. So you have to set up F net equals MA of both.
calculate acceleration.
Yeah. Okay, let's just write the question down. Okay, so what is the acceleration of the blocks? So we're going to do F net equals MA of the 6 kg. And we're going to do F net equals MA of the 3 kg. And then we're going to solve it simultaneously.
So,
There's an easy way of getting the answer actually, but you're not allowed to do that anymore. I'll just show you how to do it if you quickly want the answer. All the forces to the left is 20. All the forces to the right is 12 Newton. If I subtract that, we have 8 Newton resultant to the left. Is that correct?
so,
If I divide that with the total mass, I get the acceleration. 8 divided by 9. The acceleration is going to be 0.89. Okay, let's see if we get that. Oh, you're not allowed to do this method anymore. Because, okay, so we have to set up F net for both. I'm going to choose the direction towards the left as positive. So if I look at my forces diagram of the 6 kg, I have a force of 3 on 6 to the left plus a negative friction. And that is 6A.
friction, yes, equals to 6.
3 on top of 6 equals 6A plus the friction of 8 newtons. And that's my first equation. Did I miss anything? No. Then the other block, F net is MA. We have force applied to the left.
Force applied, yes, sir.
Plus a negative friction value. Plus another
Yeah.
negative F of 6 on 3. And that is 3A. Let's fill in some values. The force applied is 20. Negative friction, 4. And then I'm going to take the 3A over. So it becomes negative 3A. And I'm taking that force of 6 on 3 to the right. Why? I want to make these forces the subject of equations because they're both the same.
Yes, sir.
According to Newton 3, these two forces are exactly the same. So I can make them equal to one another.
Yes, sir.
So
therefore, it'll be 6A plus 8 equals to 20 minus 4 minus 3A.
Very good. And then I have 9A equals 8. A equals 0.89 meters per second squared left.
9A equal what? 20 minus 4, 16 minus, dang, that means it's 12. That means A equal, oh yeah, no. Yes, it's 8, sorry. Oh, yes, acceleration is equal to 0.89 meters per second to the left.
Yep. Okay, one more. Harder flat surface. There's a mass. It's M. I don't know what it is.
Okay.
There's another rope. Tension. And there's a block here. And let's say this is 3 kg again. Now I'm telling you that the block accelerates to the right at 1.2 meters per second square. All right. So
Yes,
maybe
sir.
that 3 kg, well, I'm just going to change that. to 4 kg. Then the coefficient of kinetic friction is 0,2.
Okay. Okay, it's kinetic friction, therefore it is moving.
Yes. But I have a
And it is,
coefficient. I don't have the friction.
okay, then the acceleration, it's 1,2 meters per second,
Yeah,
right?
this is acceleration. So I'm just gonna write here A equals to the right down. Okay, we want free body diagram on M.
Okay, 2.1. Free body diagram.
Free body diagram on M.
Okay, so we have a friction force to the left,
Okay.
yeah, kinetic friction.
Yeah.
We have the weight vector and the normal force vector, and we have the tension.
Very good.
Is
Right. Now I'm going to do something difficult. Try and make us do something difficult. I want to know what is the tension in the rope.
can I just write the thing?
Yeah.
Tension.
I tell you what, take 4 minutes, try and figure out what you're going to do.
Okay, the tension, right?
2.2.
2.2
The method is very important. You follow the same method.
in rope. Okay, I'll try solve it, sir.
Okay, good.
The tension in the rope. Okay, so that means we're gonna use F net equals MA, right, sir?
For both of them.
For both of them, yes, sir.
So I'm just going to make this drawing.
Okay, so in the square, it
4
is,
kg, eh?
yes, sir.
Because I'll
It
need
is.
that. There's no marks for that, but I need that. So I'm going to do F net equals MA for the big block and F net equals MA for the 4 kg block.
Yes, sir. Okay, so okay, for the big one, right? So you know
Yeah.
what you're gonna do? You're gonna be like the negative kinetic friction plus the tension equals to 1,2 m.
Okay, 1,2 big M.
Yes, sir. And from there, you're gonna make since we're trying to find the tension, so we're gonna make that the subject of the equation. So therefore, it's gonna be tension equal to 1,2 m plus kinetic friction.
What is the kinetic friction?
It is 0.
No.
Kinetic friction.
The kinetic friction is me N.
Times, okay.
Okay, so now we have to find that. That is 0,2 times N. N minus weight is 0.
It's
So N equals mg. Okay, what's the weight? What's the mass of the big block?
we don't have one.
So we're going to keep it m.
Mg times
And then
9,8.
So that's 9,8 times 0.2. 1,96 big M. That's the friction kinetic.
Yes.
Tension in the rope is 1,2 big M plus 1,96. Oops.
It's so isn't it 1,96 altogether?
No, there's an M there.
Oh yes.
You don't have the mass.
2m plus 1,96 m, right?
Yeah.
Then we're gonna calculate for the second block, which is negative tension plus weight.
Okay, negative tension plus weight equals
Yes,
4
1.
times 1,2.
Oh, since we have the weight, yes. 1,2.
We're gonna find out that this was probably 3 marks and we're overkilling it now.
Oh,
It's fine.
so which is we're trying to make the tension the subject of the thing. So tension is gonna equal 4,8. That is the thing, the
4
The F net.
times 9,8
Yes.
minus 4 times 1.2. Is that correct?
Yes, sir.
Okay, what happened now? Now we feel very dumb, actually. Do you realize that? Because we could have worked out the tension in a rope just by doing that part, nothing else. Okay, so what happens in the exam? The next question is going to be, what is the mass? Huh.
Yes, sir.
But we have completed all of that in one sum almost already. Do you see that?
Yes, sir.
We have set up an equation now to get the tension in terms of M. So we can use that section in the next sum. So I can just say tension equals 1,2 M plus 1,96 M. 34,4 equals what? Is it 3,16 M?
96 M. Okay, so the tension, oh yes, tension is steady.
And then I can just divide that 34. And the mass is 10,89 kg.
Nine kg. Yes.
Right. So basically what happened here, we overthought this first part. It would have been just 3 marks. And then this question on what is the mass would have been like 5 marks. But we will get our marks here. No, it will be more. It will probably be 6 marks. We'll get our marks here for that mass. And you'll get your marks here for the tension in the rope.
Also, for the tension in the rope, we only calculate for the 4 kg.
Yeah, we only needed the 4 kg to get the tension in the rope because we had the acceleration. So for the first question, we only needed basically this. But we thought, okay, let's just do our normal steps, normal method of doing it. And we followed all the steps. But we didn't lose anything because all of this green part is needed for the next sum.
So, sir,
yes.
If question, okay, let's say question 1 was tension in the rope, then wrote all of this, can they take like the marks and put it like,
You can just say there, C 1.1. Basically, we've done all the calculations in 1.1.
Oh, yes.
Yeah, they have to mark it.
So can you do one more like this?
Okay. I want to do something else quickly. Just want to check something. Say for instance, we have a slope here. And we have, let's say, another box there or something. Let's give the friction here. The friction is 10 Newton. It's actually a lot. And this is this is a lot. This is an 8 kg block. And I have another pulley system with a rope there. And this mass here is 3 kg. Can you see all of that? Let's say our slope is 20 degrees, which is not a lot. Now, normally they tell you, look, the 8 kg box is either sliding down or it's moving up. If they don't tell you which it's doing, can you actually determine if it will slide up or slide down? We can. If we ignore the friction, because the friction is always going to be against our movement or against the direction of movement. If we just look at the following, there are 2 forces on that 8 kg apart from friction. One is the parallel force, the weight parallel. That's what the 8 kg wants to do. It wants to slide down. And then there's another force, which is that rope tension. Okay? Or 3 times 9,8. If everything is standing still, if you hold that 8 kg block still, there's no friction on it if it's not moving. So if you hold it, there's 2 forces acting on it. One, a 3 kg that wants to pull it up, and a parallel force that wants to pull it down. You have to find out which of those has the highest value. The one with the highest value, it will move in that direction and friction will be in the other direction. Do you understand? So if I just stop this block, I stop it, then there's no friction. Then there's two forces. Then there's a rope pulling it up, and there's a parallel component wants to slide it down. We're going to work out which one is the highest. This one is easy. This one is, what is it, 23 times 9.8. This is 29,4. So 29,4 newtons is pulling it up. And the parallel component is mg sine alpha. And that is 8 times 9,8 times sin 20. 8 times 9.8 times sin 20. So that force is 26. This is a big problem. 26,81. So that friction force is not going to help us a lot. I'll have to make the friction like 2 newtons. Sorry, I don't have any, I don't work from any, I don't have any examples in front of me. I'm just making them up as we are talking. And sometimes I have to fix it because the 10 Newton can't work there. Okay, it's impossible to have 10 Newton friction with those two forces. Do you understand what's happened now? Without any friction, there's 29 going up and 26 going up, down. So this box will slide up. But normally they'll tell you the box is sliding up or down. I've now found 2 papers already where they've said sliding up or sliding down, and then I go and work out the calculations, and it's actually wrong. It's not possible to slide up. So I'm just testing it if it's going to work. Okay, cool. Are you happy with this? Do you understand that the box is going up? Tatu. Your mic is not working. So what I'll do is I'll just continue recording this one and I'll pass it on to you. Right, so basically the free body diagram of the 3 kg looks like this. We have tension up and mg down. And on that block, I have weight parallel, normal, weight perpendicular, and tension in the rope. Okay. So you have to set up both. F net equals MA. So I'm going to use this direction as positive. So we have negative tension plus positive mg equals 3a. Negative tension plus 3 times 9,8 equals 3a. So tension equals 29,4 minus 3a. That's our first equation for the 3 kg. Then for the 8 kg, we have F net equals MA. We have positive tension minus the weight parallel component is 8A. Tension minus mg sin 20 is 8A. We did work that out. So I'm just going to do tension, make tension the subject. And that is 8A plus 26,81. And then I'm going to solve these two simultaneously. That you can do. Then I get the tension. Oh, sorry, the acceleration. And then you can work out the tension afterwards if you want to, just by substituting it in. Okay, next week we'll look at Schnell's law and Huygens principle, and we will look at electrical currents. Maybe we should look at that first, electricity. Good. I'm going to say bye, Tatu. I can't hear you anymore. Maybe you should exit and just say bye. Please try and find a fix for that mic, or just clean that connector.